Problem 28, Quantum Mechanics. The question is, the wave function of a particle is given by psi equal to 1 by root 2 phi 0 plus I phi 1, where phi 0 and phi 1 are normalized eigenfunctions with energies E0 and E1 corresponding to the ground state and first excited state respectively. The expectation value of the Hamiltonian in the state psi is. In the question, the expectation value of the Hamiltonian in the state psi is asked. Psi is given by 1 by root 2 phi 0 plus I phi 1. Here, phi 0 and phi 1 are normalized eigenfunctions with energies E0 and E1, which corresponds to ground state and first excited state. Let us write the given wave function as ket psi equal to 1 by root 2 ket phi 0 plus I ket phi 1. Now what is the complex conjugate of psi? Ket psi, which is bra psi, that is equal to 1 by root 2 bra psi 0 minus I bra phi 1. Now let us take the inner product of psi with itself, that is equal to 1 by root 2 bra phi 0 minus I bra phi 1 into 1 by root 2 ket phi 0 plus I ket phi 1. Now we can write it as 1 by 2 the inner product of phi 0 with itself plus 1 into the inner product of phi 1 with itself. So the answer is 1 by 2 plus 1, that is 3 by 2. This is because the inner product of phi 0 with itself is 1 and the inner product of phi 1 with itself is 1. Now let us see what happens when Hamiltonian operates on the given wave function psi. That is h ket psi, that is equal to h operating on 1 by root 2 ket phi 0 plus I ket phi 1. Now we can write it as 1 by root 2 h ket phi 0 plus I ket phi 1. Now from the Schrodinger equation we have h phi 0 equal to E0 phi 0 and h phi 1 equal to E1 phi 1. Therefore, the result is 1 by root 2 E0 ket phi 0 plus I into E1 ket phi 1, where E0 and E1 are the eigen values. Now let us find out the expectation value of the Hamiltonian. That is, the inner product of psi with Hamiltonian operating on psi divided by the inner product of psi with itself. That is the expectation value of Hamiltonian. This is equal to 1 by root 2 bra phi 0 minus I bra phi 1, then h psi, that is 1 by root 2 E0 ket phi 0 plus I E1 ket phi 1. Now whole divided by the inner product of psi with itself, that we already find out, that is equal to 3 by 2. Now we can write the expectation value of h as 1 by 2 E0, the inner product of phi 0 with itself, 1 by 2 E0, the inner product of phi 0 with itself, plus E1, the inner product of phi 1 with itself, divided by 3 by 2. That is equal to E0 by 2 plus E1. Now in the expression, the second term is E1, then inner product of phi 1 with itself. So your answer is E0 by 2 plus E1 divided by 3 by 2 and that is equal to E0 plus 2E1 by 3. E0 plus 2E1 by 3. Therefore, from the given option, option D is the right option.